Hello students, welcome to AIMS India online classes. This is a chemistry session. In this session, we are going to discuss about the chapter acids, bases and salts. From this chapter, we are going to say about the chemical reactions of acids and bases. First, let us say about reactions of acids with metals. Acids react with metals to form metallic salts and hydrogen gas. Yes, when acids react with metals, the hydrogen present in the acids will be replaced by this metal. So that metallic salt will be formed and that hydrogen emitted will be evolved in the form of hydrogen gas. So, when acids react with metals, metal salts and hydrogen gas are produced. For example, zinc reacts with the dilute hydrochloric acid to form zinc chloride and hydrogen gas. Yes, here the equation is also shown. If you see, when hydrochloric acid reacts with zinc metal, this zinc replaces this hydrogen from acid molecule, acid molecules. So that zinc chloride salt will be formed and hydrogen gas is emitted out, produced out or evolved out. See here how it is done here. Experiment also shown. First, some zinc granules are taken into a test tube or conical flask. Into that, hydrochloric acid is added, and then zinc chloride is formed in the test tube, and hydrogen gas is emptied out. This hydrogen gas can be tested with a burning splinter. When a burning splinter is introduced into the play in the hydrogen gas, that burns with a blue colored flame and immediately it puts off with a pop sound. This indicates the evolution of hydrogen gas. So in this way, when acids react with metals, they form metallic salts and liberate hydrogen gas. Now let us see the reaction of bases with metals. How these bases react with metals. Bases also react with some metals to form metallic salts and hydrogen gases. But not all the bases. Some bases they react with metals and they form metallic salts and hydrogen gas. If you see example, zinc reacts with sodium hydroxide solution to form sodium zincate salt and hydrogen gas. So the same kind of experiment you can do with zinc and base also. When sodium hydroxide base is added to zinc granules, they form a salt called sodium zincate. At the same time, hydrogen gas is also liberated. So we can say acids and bases they react with metals to form their respective metallic salts and they liberate hydrogen gas. Reaction of acids with carbonates and metal bicarbonates or metal hydrogen carbonates. These metal carbonates are also called as metal hydrogen carbonates. So how these acids react with the carbonates and bicarbonates? Let us see here. Acids react with metal carbonates and metal hydrogen carbonates to form metallic salts, water and carbon dioxide. Yes, here when these acids react with carbonates and bicarbonates of metals, they form the respective metallic salt, water, and they liberate carbon dioxide gas also. Let us say for example, dilute hydrochloric acid reacts with the sodium carbonate. Sodium carbonate means it is a metal carbonate, and the sodium hydrogen carbonate means metal bicarbonate. So when this dilute hydrochloric acid reacts with these two, carbonate and bicarbonate, it forms sodium chloride salt and water and carbon dioxide gas is evolved. See here is experimental setup. If you take some sodium carbonate or sodium bicarbonate in the test tube, if we add dilute hydrochloric acid through funnel into the test tube, then this sodium carbonate or sodium bicarbonate, they react with hydrochloric acid and form sodium chloride salt and water. Along with these two, carbon dioxide gas also will be evolved out. It comes out like this. So this gas evolved can be tested with calcium hydroxide solution, which is commonly called lime water. We know that test for carbon dioxide with lime water. What happens when carbon dioxide is passed onto this lime water solution? That turns milky. Lime water turns into milky in the presence of carbon dioxide gas only. So from that we can understand that the gas evolved is carbon dioxide. So in these reactions of sodium metal carbonates and bicarbonates or metal hydrogen carbonates, acids they produce metal salt, water and carbon dioxide gas. Okay. These reactions can be expressed in equations also as follows. See here, sodium carbonate on reaction with aqueous HCl. This AQ represents aqueous, nothing but dilute. So sodium carbonate reacts with dilute hydrochloric acid to form sodium chloride salt, water and carbon dioxide gas. We have seen the test for carbon dioxide gas emitted also. What is that? When this carbon dioxide is passed on to the lime water turns milky. Why does it turn milky? Because here the sodium hydroxide or lime water reacts with carbon dioxide passed onto it and forms sodium carbonate, which is insoluble solid substance. So by the formation of that, it appears like a milky layer. So in this way, carbon dioxide gas is tested. If you see one more equation, that is a reaction of acid with metal hydrogen carbonate, which is also called bicarbonate. Here it is taken sodium bicarbonate. Sodium bicarbonate on reaction with aqueous hydrochloric acid forms here also salt, water, and carbon dioxide gas. Okay, metal carbonates and bicarbonates on reaction with acids they form metal salt, water, and carbon dioxide gas as products. We can write generalized form of these chemical reactions as shown below. Yes. So what we have observed in the from both the reactions, we can summarize like this. Metal carbonate plus acid gives salt, water and carbon dioxide. Even metal hydrogen carbonate also on reaction with acid forms salt, carbon dioxide and water. So both are forming common products, salt, water, carbon dioxide. If we pass the gas evolved through the lime water, it turns lime water milky. Yes, we discussed this. Test for carbon dioxide gas evolved in these reactions. If we pass this gas evolved in these reactions through lime water solution, that lime water solution turns milky. So, for that reaction also, equation is shown here. So, lime water nothing but calcium hydroxide solution. When you pass carbon dioxide gas into that, it turns milky. That milkiness is because of the formation of this calcium carbonate, which is an insoluble solid substance. It floats on the water like a thin layer. That is nothing but that milky layer. That milky layer is because of the formation of this calcium carbonate. This calcium carbonate is white color substance which is insoluble into water, so it appears like a milky layer on the calcium hydroxide solution. So anyhow water also will be formed. Now we pass some more amount of carbon dioxide, nothing but on passing excess of this carbon dioxide, the following reaction takes place. By that, the milky layer formed first will be disappeared. Why? Because here, if we pass continuously this carbon dioxide onto this calcium hydroxide solution on which a milky layer is formed already, this milky layer reacts further with carbon dioxide in the presence of water and forms a calcium hydrogen carbonate, which is also called calcium bicarbonate. This calcium bicarbonate is water soluble, which is soluble into water, so it disappears. It dissolves into water. So that a white layer obtained at the starting will be disappeared after certain time if you pass carbon dioxide continuously onto that. So by passing excess of carbon dioxide, that milky layer obtained will be disappeared because of the formation of calcium hydrogen carbonate. So this calcium carbonate turns up into calcium hydrogen carbonate, which is soluble into water. So that milky layer disappears. Okay. Now let us say about acid-base neutralization reactions. The reaction of an acid with a base to give salt and water as products is known as neutralization reaction. In general, a neutralization reaction can be written as this: an acid plus base gives salt and water as products. This generalization is called neutralization reactions. For example, dilute hydrochloric acid solution reacts with a dilute sodium hydroxide solution to form sodium chloride salt and water. Here, acid hydrochloric acid reacting with a sodium hydroxide base and forming sodium chloride salt and water as products. Acid and base reacting together to form salt and water. These reactions are generally called neutralization reactions. Acid is neutralized with base. So these are called neutralization reactions. So this we can show as equationally like this. Base reacting with acid to form salt and water. Okay. Reaction of acids with metal oxides. Metal oxides react with acids to give salt and water. These reactions are similar to the reactions of acids with the bases that we have observed. Yes, in the previous example we have seen sodium hydroxide base reacting with hydrochloric acid to form salt and water. In the similar way, these metal oxides also they react with acids to form salt and water. So the reaction of metal oxides also resembles the reaction of bases, how they react with acids. So we can say generalize the equation like this. Metal oxides react with the acids to form salts and water. So this is similar to the reaction of bases with acids to form salt and water. For example, copper oxide reacts with the dilute hydrochloric acid solution to form copper chloride, salt and water. So what is happening here? This metal oxide, copper oxide reacting with acid, that is hydrochloric acid, to form a salt sodium chloride and water, which is similar to the reaction of bases with acids. In the previous example we have seen sodium hydroxide base reacting with hydrochloric acid to form sodium chloride and water as a products. That is said neutralization reaction. So here in the same way, here copper oxide or metal oxide also reacting with the acid to form salt and water. Thus, we can conclude that metal oxide are also basic in nature, like the metal hydroxides. So what we can say here, these are also forming neutralization reactions with the acids. So we can say these metal oxides are also basic in nature because these metal oxides are also forming salt and water on reaction with acids, just like the metal hydroxides. So we can say these metal oxides, metal hydroxides, both are basic in nature. Okay. Reaction of base with non-metal oxide. We have seen that the reaction between carbon dioxide and calcium hydroxide. Yes, we have seen that, no? Lime water turns milky in the presence of carbon dioxide. What is that? The reaction of carbon dioxide with lime water or calcium hydroxide. Calcium hydroxide, which is a base, it is reacting with carbon dioxide to produce a salt and water. What salt is formed in that? Calcium carbonate salt is formed, along with that water also formed there. This reaction is similar to the reaction of acids with bases, isn't it? So what we said in the reaction of acid and base, they form salt and water. Here, carbon dioxide also forming salt and water on reaction with a base. So this is similar to the reaction of an acid with base, isn't it? See here, calcium hydroxide is a base, we know. This on reaction with non-metallic oxide or carbon dioxide, it is forming a salt calcium carbonate and water is formed. What we can say here, thus we can conclude that carbon dioxide, which is a non-metallic oxide, is acidic in nature. In general, all non-metallic oxides are acidic oxides or acidic in nature. So previously we have seen metallic oxides are basic in nature, just like metallic hydroxides. Here, in a other way, non-metallic oxides are acidic in nature, just like the acids. Because these non-metallic oxides also, they are reacting with the bases on forming salt and water as the products. They are also causing neutralization reaction with bases. For example, we have seen here carbon dioxide on reaction with base calcium hydroxide forming a salt calcium carbonate and water. So here carbon dioxide is acting as an acid in this. Neutralization reaction is caused by carbon dioxide. So from this we can conclude that non-metallic oxides are acidic in nature, just like the acids. Just like the acids, these non-metallic oxides also causing neutralization reactions or reacting with the bases. But of course, in general, we have to say all the non-metallic oxides are acids is not correct. Some are there, some neutral oxides are there, but in general, non-metallic oxides are acidic in nature and on reaction with the bases they form salt and water. Reaction of non-metal oxides with bases. We have seen that reaction between carbon dioxide and we have seen this no. Now let us see the properties of acids. We have observed that acids generate hydrogen gas on reaction with metals. So hydrogen seems to be common element in all acids. Yes, mostly all the acids on reaction with metals, they are forming metallic salts and they are liberating compulsory hydrogen gas. So from this we can say all the acids they have hydrogen in them as in common. All the acids almost they contain hydrogen in them in common. Because that's why only when these acids they are reacting with the metals they are liberating hydrogen gas. Acids produce hydrogen ions in solutions, which are responsible for their acidic properties. Yes, as we told, these acids they have hydrogen in common. So when these acids dissolve into water or when they are forming solution, they liberate these H plus ions or hydrogen as ions. Suppose example, if you take hydrogen chloride HCl, which is an acid, it is having hydrogens in it. When you make it a solution, means when you dissolve this into water, then this hydrochloric acid releases H plus ions or hydrogen ions, which are responsible for the acidic nature of the hydrochloric acid. So hydrogen ions are responsible for the acidic nature of acids. See here, as we told, HCl on dissolving into water. So in the aqueous form, in aqueous solution, hydrochloric acid ionizes or splits or separates into H plus ions and Cl minus ions. So acid liberating these H plus ions. So these H plus ions are responsible for the acidic properties. But all the compounds containing hydrogen are not acids. Yes, it is also very important. We are telling acids are having hydrogens in common in them. When you dissolve these acids, they are producing H plus ions. These H plus ions are responsible for the acidic properties of those substances. But the compounds which are having hydrogens in them are all not acids. For example, if you see glucose, alcohol, these compounds are also having hydrogens in their molecules, but they are not acids. So, the compounds which are having hydrogens are not all coming into acid form. Okay? All the compounds containing hydrogens are not acids. Only few of them are acids. Example, glucose, alcohol. These compounds are also having hydrogens in them, but they do not come under acids. Now let us see properties of bases. On dissolving bases into water, they produce OH minus ions in common. These OH minus ions are called hydroxyl ions or hydroxide ions. They are called hydroxyl or hydroxide ions. OH minus called hydroxide ion or hydroxyl ion. These bases on dissolving into water, they produce these hydroxyl ions. For example, if you dissolve sodium hydroxide into water, if you make aqueous solution of sodium hydroxide, this produces Na plus ions and OH minus ions. These OH minus ions are called hydroxyl ions. So not only this, in common, bases on dissolving into water, they release these OH minus ions. How acids produce H plus ions? In the same way, bases produce OH minus ions on dissolving into water. One more example, potassium hydroxide, KOH. This potassium hydroxide on dissolving into water, it produces OH minus ions or hydroxyl ions along with K plus positive ions. Okay, in general we can say bases on dissolving into water they form hydroxyl ions. One more, magnesium hydroxide. This is also releasing OH minus ions along with magnesium plus 2 ions. Bases which are soluble in water are called alkalis. So there are different kinds of bases. So many bases are there. Out of these, most of them are soluble into water. So those bases which are soluble into water are called alkalis. Some bases are not soluble into water. They are not called alkalis. So we can conclude this as all the bases do not dissolve into water. Very few of them are insoluble into water. Those as bases which are soluble into water are called alkalis. So all alkalis are bases, but all bases are not alkalis. This we can conclude from this. Dilution of acids and bases. Yes, it is very important process in the general laboratories. In our schools also we might have seen some laboratory and chemicals. There we use some acids in the experiments. Those acids are dilute acids. And even bases also we take in the form of dilute bases for our experiments. We cannot take these concentrated or pure acid or pure base for our experiments because they may cause some explosions. Because we know acids and bases are more reactive, even more corrosive also, dangerous. We should not take them directly. So for taking into the experiments, first we make them diluted. Diluted means water added. The process of dissolving an acid or base in water is called dilution and it is an exothermic process. What does it mean here exothermic? Exo means evolution. Exothermic means heat energy is evolved. The dilution process means addition of water to acid or base, or addition of acid or base to water is called dilution of that acid or base. This dilution process is a heat releasing process, that is exothermic process. So as it is being exothermic process, care must be taken while mixing these concentrated acids with water. The acid must be always added slowly to water with constant stirring. Suppose we want to prepare some dilute nitric acid. Generally in the laboratory, in bottle there will be concentrated nitric acid, which is more dangerous, more corrosive. We should not touch them with the bare hands. It may spoil our skin. So what to do? First we have to take water into a beaker or bowl. To that, few drops of nitric acid should be added slowly, as it is shown in the picture here. See, they are dropping this nitric acid with the pillar. Drop a drop into water. And while adding this, we have to continuously stir the water so that we can add comfortably acid into water that we can make dilute acid. Okay, even sulfuric acid, hydrochloric acid also should be diluted in the same form. Acid should be added to water with continuous stirring slowly. Then we can make dilute acids with the same. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. So the glass container may also break due to excessive heat production. Yes, we never add acid, water to the acid. We should not add water to the acid. That may cause evolution of huge amount of heat energy immediately and may cause an explosion there. See, as it is shown in this, it may cause some blast also, breakage of this equipment also. That is why we should not add water to the acid. In the dilution process, always acid should be added to the water with a slow process and with continuous stirring. By this process, we can make dilute acids, but we should not add water directly to the concentrated acids. Okay. Thank you for watching our video. Please visit our website aimstoday.in and subscribe our YouTube channel Aims Today for latest updates and thank you.